Well, hello everyone. First off, I'd like to start by saying thank you so much to the Apollo team for inviting me to give this talk today. So a bit of my background before we jump in. Again, my name is Mandi, and I've been using GraphQL since early 2017, and I started teaching other people how to use GraphQL shortly after that at a boot camp I used to work at. Fast forward to late spring 2019, I decided I wanted to consolidate everything I had learned about building complex GraphQL APIs over the years into a book. And I ended up getting about a week or two of work done on the book before I woke up one morning, checked Twitter, and saw that Apollo Federation had been launched. After I took a look at its documentation, I promptly decided to throw out all of the content I had just developed on schema stitching and ended up basing the book on Apollo Federation instead. So today, I'm going to show you just how easy it is to get up and running with Apollo Federation. So on that note, I'm just going to flip over to Keynote now. Okay, let's dive in. So the roadmap for my talk today is that I'm going to give you a quick rundown on what Apollo Federation is and why we would want to use it. We're going to do a little bit of a demo refactoring a vanilla Apollo server into one using Apollo Federation, and then we'll finish off with a little recap. So let's start off with answering one of the big questions. What is Apollo Federation? So Apollo Federation is a set of tools that allow us to compose multiple GraphQL schemas declaratively into a single data graph. Now that's a bit of a mouthful, so let's explore what that means a bit more visually. So when using Apollo Federation, we're going to have multiple implementing services, and each of those services are going to have their own GraphQL schema. In front of those services, we'll add a gateway that composes those schemas into a single federated data graph so that clients, perhaps a web client and a mobile app client, can then query a single GraphQL API without needing to worry about the implementation details of the underlying services. So what problems does this solve? Well, one of the most compelling reasons to create a GraphQL API in the first place is that it allows us to expose one data graph, potentially with multiple data sources behind it, like a REST API and a SQL database. And then we can query the data in a way that reflects the relationships between the nodes in the graph. However, as we expose more and more objects and their relationships through various types and fields, it doesn't take long for even a moderately complex app to require a large number of type definitions. In turn, it becomes difficult for multiple people or teams to collaborate on building the API, and what's more, the GraphQL API then becomes a single vulnerable point of failure in the system. The solution would then be to create a distributed GraphQL architecture and break up the schema into multiple smaller services for development purposes, but then recombine each separately managed portion of the schema into a gateway API so that client applications can remain agnostic to these divisions when querying data. Before Apollo Federation, there was an existing solution to do this called schema stitching. However, with schema stitching, there tends to be a necessity to split a schema, sometimes awkwardly based on types, and it also requires a lot of boilerplate code to effectively consolidate the data graph. And that again introduces a single point of possible failure into our application architecture. Apollo Federation addresses these issues by allowing us to split a schema based on separation of concerns rather than by type, and also takes care of the heavy lifting when it comes to combining federated schemas into a single data graph for clients to query. So it really is like having your distributed GraphQL architecture cake and eating it too. Now, before we jump into the demo, we're going to need to wrap our heads around a few key federation concepts. The first is the notion of an entity. An entity is a type that you define canonically in one implementing service and can then reference and extend in other implementing services. Entities are the core building block of a federated graph. They're the things that allow us to split schemas based on separation of concern rather than by types alone. And we're going to create entities using an add-key directive in our schema. Once we define an entity, we can then reference it from other services as needed. Other services that reference the entity will only be able to return a representation of that entity from any corresponding resolver. So the gateway is going to have to hand this representation off to the entity's originating service, which means we're going to need to provide what's known as a reference resolver in that originating service to fetch the data for that specific entity. And last but not least, we can even add additional fields to a type originally defined in another service by extending that entity in a referencing service. Okay, so to create a federated data graph, we're going to need to make use of some additional Apollo libraries. So first of all, we're going to need the Apollo Federation library, which allows us to make our services schemas Federation ready. We're also going to need the Apollo Gateway library, which is going to help distribute incoming GraphQL API requests to the underlying services. And lastly, we're still going to need Apollo Server because we're going to need an instance of Apollo Server for the Gateway API and each of the implementing services we create. Okay, now that we have some awareness of what Apollo Federation is and why we'd want to use it, let's walk through a quick demo of refactoring a regular Apollo server into a federated data graph with 2 implementing services. So over in VS Code, I've already set up a basic GraphQL API. And this GraphQL API wraps a REST API that provides us a little bit of data about Apollo astronauts and their various missions. So I hopped over to Chrome. We can see that we have an astronauts endpoint here that will give us an array of astronaut objects containing their names. And we also have a missions endpoint, which gives us some data about the missions, including their designation, a start date, and an end date, as well as an array of crew member IDs, which are references to the astronauts' IDs over here. Now, in GraphQL Playground, I already have this GraphQL server running. So if I query the astronauts by name, I can in fact see that list of astronauts listed here. Okay, so back over in VS Code, we're going to start working through the steps of converting this into a GraphQL API that uses Apollo Federation. So the first thing I'm going to do is stop the server for a moment, and I'm going to create a new file to contain all of the code for our astronaut service. And I'm going to start by doing a little copy pasta here. I'm going to grab all of the code from our index.js file and I'm going to paste it over into astronauts.js. Now we're going to need to make a few changes to this file to turn it into an implementing service. So the first thing we're going to need to do is import build federated schema from that Apollo Federation library. The next thing we'll do is we'll set a unique port number for the service because it's going to need to run on a different port from the Gateway API. Then we're going to make a couple changes to our type definitions. So the first is that we want to turn this astronaut into an entity. So to do that, we'll add the @key directive and set its field to ID, which means that whenever another service references an astronaut, as long as that service knows the ID of the astronaut, the gateway is going to be able to help us resolve that field. Next up, we're going to put the extend keyword in front of type query because the query and mutation types originate at the gateway level of our API. So the Apollo documentation says that all implementing services should extend these types with any additional operations. Next, instead of passing the type defs and the resolvers directly into Apollo server, what we're going to do is set a schema property with a value of build federated schema. And into build federated schema, we'll pass an array containing an object which has our type defs and our resolvers in it. And then last but not least, we're going to update this console log message just so that it's obvious that our astronaut service is ready. Now we're going to need to make some changes to our original index.js file to turn that Apollo server into a gateway. So the first thing we're going to do is we can get rid of this fetch import because we won't be making any direct requests to our REST API from this file anymore. We can get rid of the GQL tag import. We can get rid of this constant here. We can also remove the astronaut type definitions and resolvers. But what we're going to need to add is an Apollo gateway. So to do that, we're going to import Apollo gateway from the Apollo gateway package. Then we're going to create a new gateway by instantiating a new Apollo gateway. And into that Apollo gateway, we will pass a service list, which will be an array. And inside that array will be objects representing each of the implementing services that we want to add into our single federated data graph. So our first service will have a name of astronauts and a URL of HTTP localhost 4001. Now, in our Apollo server, we no longer have type definitions or resolvers to pass in, but we do have a gateway, and we're going to set subscriptions to false because at this time, Apollo Gateway does not support subscription operations. We'll give that file a save, and we have one last thing to do before we can start up our GraphQL API again, which is to go into package.json, and we're going to add a script to start that new astronaut service. So we'll use nodemon to start up that astronauts service. Okay, with this code in place, we're ready to start up our GraphQL server again. So we can npm run server, and we can see that our astronaut service has started up now. And if we hop back over to GraphQL Playground and run our query again, we'll see that everything works exactly as it did before. Okay, now that we have our astronaut service up and running, let's go ahead and add a mission service. So back over in VS Code, I'm going to stop our GraphQL API momentarily, and I'm going to create a file to contain the code for our new mission service. And inside of missions.js, I'm going to add some boilerplate for creating our new service. So what we see here will look pretty similar to what we just saw in the astronaut service, except of course we're going to need to run this service on its own unique port. And our mission service is going to be responsible for managing a mission type. So we're going to go ahead and add that type definition in, as well as queries for getting an individual mission or a list of missions. And we're also going to need some resolvers for fetching that data from our REST API. And they're going to look pretty similar to what we saw in the astronaut service. So I'm just going to copy and paste those in again to save a bit of time. So with our basic mission service setup, we can go ahead and make a connection between our astronaut type and our mission type. And we want to do that so we can add that crew field in to our mission type. And from that crew field, return a list of astronaut objects. So we'll add a crew field, which will be a list of astronauts. Now, to use the astronaut type in the service, we're going to need to define it in the service as well. So we will use the extend keyword to define our astronaut type here. And once again, just like we did in the originating service, we're going to need to add a key directive and set fields to the ID of the astronaut. And because we're using the ID as our key, we're going to need to redefine that ID field here. But this time we'll put an @external directive onto it so that Apollo knows that this field was defined over in the originating service. Now our code won't quite work as it is right now because we need to resolve this crew field inside of the mission service. So to resolve this field with Apollo Federation, we only need to return an object, or in our case, a list of objects representing all the crew members that contain a type name property and an ID property to identify that object when the request is forwarded on to the astronaut service. So to do that, I'm going to scroll down to my resolvers here and add a resolver for the mission's crew field. Now in this resolver, we map over that crew array and return a new array of objects which contain a type name property and an ID property. The next piece of the puzzle is to add what's known as a reference resolver to the astronaut service. So if I jump back over to my astronauts.js file, I can go ahead and add that reference resolver for the astronaut type, which is going to be a method called resolve reference, which has the reference object as a parameter And this resolver is going to actually need to do the work of fetching that data from the astronaut's endpoint, just like we do here below for a single astronaut query. But this time we're going to pull the ID off of that reference object. So before we can start up our GraphQL API again, we're going to need to add our new mission service to the gateway. To do that, we'll add the mission service to the service list, giving it a name of missions, and it will be running on port 4002. And over in package.json, we're going to need a start script for that as well. So we can call that missions, and we'll be using the missions.js file here. Okay, so if we run npm run server now, we'll be able to start up our gateway API as well as our two services. Jumping back over to Chrome, if we go on GraphQL Playground right now and run a missions query, we can see that we get a list of missions with their designation names, and we can even add a crew field now and get that list of the crew members with their names too. So this is looking pretty good, but it would be great if we could traverse the graph in the other direction too, from astronauts to their list of missions. To add a missions field to the astronaut type, we actually don't need to touch any of our existing code in our astronaut service. We can actually extend the astronaut type directly from within the mission service with an additional field containing that list of missions. So if we head back over to VS Code now, in our missions.js file, we can scroll back up to our type definitions here and add a missions field, which will be a list of mission objects. And then once again, we're going to need to resolve this field from within the mission service too. So we'll go ahead and add a resolver for that new missions field on the astronaut type. And we'll have to keep in mind that, again, we only have access to the data about astronauts that exist within the context of the service. In other words, we only have their unique IDs. So due to some funkiness with the mocked REST API when it comes to selectively querying resources based on a value inside of an array field, we're going to have to settle for fetching all the mission data and then filtering out the mission objects that don't contain the astronaut's ID in the crew field. But we're dealing with a small amount of data here, so this is okay for our demonstration purposes. I'm also going to make this resolver async so we can use a wait inside this resolver so it's a little clearer what steps we're going through. Okay, so our first step will be to fetch that missions data. And we're going to go ahead and get that missions data from our missions endpoint like we have before. And then we will parse that response. So what we're going to do is return an array from this resolver by mapping over the missions array and returning only the objects that contain the astronaut's ID in the crew field. So to do that, we will return missions filtered. We'll destructure the crew field out here, and we're only going to keep the mission objects where the crew field includes the astronaut's ID. And we're going to need to parse that ID as an integer. Okay, so if we hop back over to GraphQL Playground now, if we go to the astronauts query, we can now get a missions field with the astronauts query, and let's get the missions designation name. Okay, so now we have the astronauts and we can also see what missions they participated in. And that's it. We now have our federated data graph and our gateway API up and running. So, just to recap what we walked through today, we created a federated data graph, 2 implementing services, and an astronaut entity. We referenced the astronaut entity in the mission service, where we used it for the crew field on the mission type. And we even extended the astronaut's entity in the mission service by adding a missions field to it so we can traverse the relationships in this graph in both directions. So if you'd like to see the complete code for this demo, I've posted it over on my GitHub here. And that's all I have for you today. Thanks so much. I'd be happy to take some questions now. Okay, so I've been keeping track of some of the questions that have been coming through Zoom. So the first question that I have here is from John. And the question is, can Gateway work with GraphQL servers that do not use Apollo and might not even be written in JavaScript? So the Apollo Federation documentation actually has a page on this called Third-Party Support for Apollo Federation. And in the documentation, they provide a list of all their known open source GraphQL server libraries that have built-in support for Apollo Federation. So I would encourage you to take a look at that. The next question we have here, is it mandatory to redefine the ID field locally at the service level and even the resolver to pull it from the gateway? Can it be inferred from the @key directive? So that's another great question. It's asked by Andrea. Yes, you have to redefine the ID field locally. The field that you define with the @key directive is actually pretty interesting. So in the example that I gave in my demo, we just used the ID field as the key, but you can actually define multiple fields as a key just by separating them by a space within that field's value. So yeah, definitely take a look at the Apollo documentation if you're interested in doing something like that. So the next question I have here is, if the referenced objects are a list, is it possible to retrieve them from a list endpoint rather than getting each of them separately? And this one was asked by Tom. So thanks for your question, Tom. So I'm not sure if I saw this question come through while I was still giving the demo. So I'm not sure if the remainder of the demo helped answer this question for you, but the key with the referenced objects is that you need to make sure that from the resolver, you're returning an object that contains that type name field as well as the ID. So if it's a list, obviously they're going to need to be in a list format, or if it's a single object, you would just return a single object from the resolver, and you can see an example of that again in the Apollo documentation. So hopefully that helps answer your question. Again, how you end up ultimately resolving those referenced objects in the originating service is going to be up to you. Okay, let's see if we've got any more questions coming in here. If I'm using a data loader, are the astronaut missions requests batched? So this is another great question. So this, there's some different dimensions to this. So under the hood, the Apollo Gateway is doing some work to batch requests that it's sending from one implementing service to another implementing service. However, once that data gets to the implementing service, the same rules still apply with respect to how you're going to need to batch operations to reduce the number of requests you're making to your database or whatever the case might be. So yeah, there's some automagic batching of requests happening under the hood between services, but once that request gets to your service, it's 100% on you to figure out how you're going to deal with that using data loaders. Let's see, what else do we have for questions here? If multiple services have the same exact operation or field name, how would you specify which one to use when composing your query? So I think I might answer this question in a more general sense, because you might be wondering about also redefining types across multiple services. So when Apollo Federation first launched, did some initial experimentation and found that it was a bit tricky to try to have types, objects, interfaces, enums, whatever the case might be, defined in one service and then have the same type used in another service. Initially, it would throw errors, but there's been a ton of work done on these libraries over the last year or so, and there's now support for reusing different types across services, which is amazing. So you can reuse things like objects and interfaces and scalars and unions across services. There's just different rules for how exactly you have to go and redefine those types across the services. So again, I would just encourage you to take a look at the Apollo Federation documentation for those specific rules. Okay, so I'm going to take one more question. I'm going to take the question from John here. Is it possible to run your mission service on its own in its own GraphQL playground? So yes, if you went to localhost 4001 or 4002 to look at the astronauts service or the mission service directly, you could actually see it there in GraphQL playground. Okay, so that's all I'm going to take for questions right now because we're on 11 a.m. here right now. So I am going to hang around in the Slack Federation channel for a little bit to answer some additional questions. If you have any, you can just throw them in there. And now I'm going to hand things back over to our MCs, Eve and Alex.